As we start off class today and you plug in this summation formula using, hopefully you guys know where to find it in your calculator. And as you plug in the actual nth partial sum, trying to figure out how I plugged in, what I did, where I did. You guys could definitely put 0.3 instead of 3/10. I was just being snazzy, but no, I'm not going to raise 3/10 to the 12th power in my head. No way, Jose. As you plug this in, my question is, if this was an infinite sum, you guys know what I mean, right? Infinity on top. If this was an infinite sum, would it converge or diverge? Ready, set, go. Let's take about a minute and a half. Talk it out in your groups. Feel free. Shoop, shoop, shoop. Tests are gone. Corrections are gone. Tests are gone. Corrections are gone. Here we go. Section 9.3, everything geometric. So, summation notation. We saw this in section 9.1, yeah? Summation notation. The long story short says, here's a formula that the entire sum seems to follow, or does follow. Here's a formula the entire sum seems to follow, and we can plug in, or does follow, plugging in 1 and 2 and 3 and 4, stopping at n. So for this one, it's technically called the 12th partial sum because it's a sum of the first term, second term, third, etc., the first through 12th terms, which I didn't even finish up writing or adding yesterday. Because I said, okay, yeah, we could go ahead and solve all of those and then plug them all in our calculator and find it. Hopefully you guys went and found the sigma when I told you to solve for the summation. Where'd you find that in your calculator? Math. Then up a little bit, right? Summation. You can plug the whole thing in. You could have used like alpha I, but what else could you have used in its spot or in its place? X. X would have been easier to push the button for. But where? Well, not where. It's right there. But how did I plug into this one? Plug into this one. What did I see when I was comparing this expression with this expression? Who was my A1? 4. Who was my R? 0.3 or 3/10. And the only reason I was able to do that perfectly was because it all matched up. So even though this one did perfectly match up and I was able to pull out the information, I could have also just looked at my series and said, oh, who's the first term? 4. That's 8 sub 1. Who's my common ratio? What am I multiplying by every time? 0.3. And then what was I plugging in for n? 12. Now, whether you guys solved it this way or that way, first of all, did the answers match? Hopefully the answers... They did match? Good. And then what did they match to be? So my S sub 12 ended up being... You guys agree? Okay. Didn't I ask a secondary question? Interesting. Diverging. So maybe you guys saw it started at 4 and now it's all of a sudden at 5.7143. So then you might have answered diverging. However, Eileen, help real quick. Geometric series, R is 3/10. Diverging or converging? Yeah. Struggle. How could you guys have figured that out, though? You didn't take BC. You don't. It's a fraction. R is a fraction. That's true. But what else could you have thought of? Plugging in higher numbers? Because I said, what about the infinite one? The infinite one, wouldn't that have a top bound of infinity? Right? So that'd be I equals 1 to infinity of 4 times 0.3 I minus 1. How could you have gotten closer to infinity from 12? We did this. What could you have plugged in? 100, 500, 1,000. Okay, who's going to take 100? Thomas has 100. Who has 500? Oh, Jack has 1,000. Who wants 500? You got 100,000. Oh, is it already thinking, or do you have it already? Oh, he's going to do it and have it thinking. His poor calculator's going to die. So then, David, you take 500. So we have 100, 500, 1,000, then 100,000. We're just making the jump. Okay. And as they're plugging in, hold on, pause. I want the rest of you to write down the notation of the limit as n goes to infinity. Remember how we talked about limit notation just a little bit? Limit. We're trying to say, is there some sort of boundary to where it's headed, where it's going, what it's doing? As n goes to infinity. Is there a boundary? Does it converge? As n goes to infinity of, we can say this guy. I equals 1 to n of 4 times 0.3 to the I minus 1? Donde? Oh, it's my sigma, just me being messy. You guys should try it sometime. If you're like writing like way down, it's kind of hard to be, I don't know, it's hard to be nice and neat. But it's going to end up being the limit as n goes to infinity of s sub n, which is the same thing as the limit as n goes to infinity of a sub 1. Ooh, we know that is 4. 1 minus 3/10 to the n all over 1 minus 3/10. We're going to think about it mathematically in just a second, but for right now, experimentally, I had some people finding some different sums for me. So first of all, what's s sub 100? Okay, how about s of 500? Same thing all the way down to uh-oh. What do you guys think is going to happen as we keep going? S of 1,000, Jack. How about S of 100,000? John, still thinking? Okay. What do you guys think it's going to look like? How is that possible? The decimal keeps getting smaller and smaller and smaller and smaller as you keep raising it to higher and higher and higher powers. Because at first you'd have 3/10. What happens when you square 3/10, guys? Not 300ths, 900ths, right? Okay, so you have 0.3, then you have 0.09, and then what happens if you cube 3/10? Wouldn't that be 27 thousandths? 7. It's going to end up being a smaller and smaller decimal that you're multiplying by every time. However, beware. One of the big things I needed to teach BC in these sequences and series is, and I showed you guys a little bit with the 1 over n and the 1 over n squared, just because the terms are getting smaller as you add, does that necessarily mean it converges? Remember 9-1? The 1 over n diverged, the 1 over n squared converged. Both of them, as you went higher and higher, they both had terms that were getting smaller and smaller. However, one went to infinity and one went to a constant. However, can't we tell this is truly converging? It's not a guess. It's a sure thing. But I want to show you in the math how we can know for sure any geometric series only right now. Any geometric series only when it will converge and when it will diverge. Look at the math. Infinite sum right here, right? Infinite sum says take a finite sum and have the n approach infinity, which you guys did in your calculators. However, we just saw, wait a minute, hold on, for geometric series, I can write this a different way using s sub n instead. I can write this using the a1, the first term, a sub 1, times 1 minus r to the n all over 1 minus r. Mathematically, why is it solid? Why is it a good conclusion? Why is it definite that this will converge? What keeps on getting smaller and smaller? Yeah. Spotlight n. Where's the only place n shows up? So where's the only place that anything's getting plugged in bigger and bigger and bigger? And what did we just say about 3/10? 3/10 squared, 3/10 cubed, 3/10 to the 4, 3/10 to the 100, 3/10 to the 1,000, 3/10 to the 10,000ths. What's going on to this little baby fraction? It's getting smaller and smaller and smaller until Colby said the word insignificant. That's one way of thinking about it. Negligible is a little bit more technical of a term to use. We could say as n goes to infinity, this term is going to approach 0. As n goes to infinity, I actually want you guys to show this expression. It's very important. as n goes to infinity. This is the introduction to chapter 12, which is the last chapter and is the beginning of calculus. The limit as n goes to infinity, we can say this term, which has the n in it, will be approaching 0. And because we can say it's approaching 0, guess what we can say? The infinite sum not only converges, we can say what it converges to. And it will converge to 4 times 1 over 1 minus 3 tenths. Without a calculator, without having poor John making his calculator think and almost internally combust to go to 100,000, I can say the sum is definitively, is exactly, is perfectly 47ths. How'd I do it? I changed the sigma to the nth sum formula, which only works for geometric series. I highlighted, I zoomed in on where the n was present in the formula. I said as n gets higher and higher and higher, this entire expression right here will go to 0. And so therefore, the limit, what's going on, the difference becomes negligible. Or as this term approaches 0, what is left, what is still remaining? 4 times 1 over 1 minus 3 tenths, which is the same thing as 4 times 1 over 7 tenths, which is the same thing as 4 times 10 sevenths. Did you guys plug that decimal in? What'd you get? But it's not off by any decimals, even down here in the 100,000, 10,000th place. It's perfect. 47ths. Dun, 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 dun. Dun, dun. Now question. Will this always be true for every geometric series? Why not? What if I was to give you something like, let's have some fun with it. What if I was to give you this one? It's going to go straight to infinity. Well, kind of. That's kind of an oxymoron, but that's okay. From 1 to infinity of oops, not equals 1, minus 1. I want you guys, maybe even in your groups, to try to go ahead and follow the exact same process to figure out, does this converge or does this diverge? You can probably guess by how I've led into this problem what it will do. But I want you to think about how the math can prove it. Go. Not the calculators. Not the calculators. The math. How can the formulas, how can what we know about a geometric series prove it? Go. Follow my process. That makes sense. It's thinking hard. It's thinking real hard. Wait, why aren't we plugging into the formula, the S sub n formula? Where is it? Well, it doesn't count. Put it in. You won't remember tomorrow, let alone 2 weeks from now, what we did today. Write it down. In chapter 12, I need you to remember this. Eileen, are you all done? Can you do me a favor? Can you steal some of the scratch paper and just make me signs for all my periods 1 through 6? I don't know what markers are better or not. You can just test them all. But write period and then the number, and then just do a little down arrow. It's going to be for Pi Day stuff tomorrow so that we can have contributions go in there. Thanks, kid. 1 through 6. Whew! You guys ready to check? First question, did you change it to the limit as n goes to infinity? If not, you're wrong. You might be partially right, but I would take off points. Just a warning. Notation is super important. Who plugged into the S of n formula? What did you get for this series? Good. Now, just in case, I know some of you are still catching up, that's how you would plug into the formula. We haven't done the math yet in the sense of thinking about, okay, now as n goes to infinity, I can kind of see the n. I can think about it going to infinity. I'm just going to write out the series really quickly for you. If I plug in I is 1, 1 minus 1 is 0, anything to the 0 is 1. My first term is 1/2. As I go to the next term, I would have 1/2 times -2, which would be interesting, a -1. Then I would have plus 1/2 times -2 squared, which would be 4. So that'd be 2. Then I would have minus, going to have times another 2. If you guys had seen this, I'm not sure that all of you right away would have said, oh, of course it's divergent. Maybe you would have figured that out. Maybe you wouldn't have. But my question to you is, yes, it does diverge. Yes, we would have to say, in a sense, the limit does not exist. Ooh, Mean Girls. However, very different type of problem than the Mean Girls one, but that's okay. Coming back. She only got it right because she remembered hair. I don't even know. Anyway, back here, if you've never seen Mean Girls, it means nothing. Just ignore everything I just said. When n goes to infinity, P.S. it's a movie. That's a thing. I don't know. These days, I feel like everyone just watches Vines and little snippets, and like your attention span is for 30 seconds. In the olden days, we used to quote movies. Yeah, it was a thing. Coming back. As n gets bigger and bigger and bigger and bigger, -2 to the 10th, -2 to the 100th, -2 to the 50th, -2 to the 47th, doesn't matter. As -2 gets bigger and bigger and bigger, or the powers get bigger and bigger and bigger, what's going on to this guy? It's getting closer to positive or negative infinity. That's the trick, because technically it's bouncing. And it's going to positive infinity 1 second and to negative infinity the second. So first of all, it can't make up its mind. No allusions to real life. It can't make up its mind. It's going back and forth and back and forth. So technically, we would say this one doesn't even really go one place. We would just say this diverges. We would just say it diverges. If it can't make up its mind, if it's not going to one set boundary, if it's not going to one set limit, we can't even really say what it's going to. But Patricia kind of hit on it. It is going to positive infinity some of the time. It's going to negative infinity the rest of the time. Long story short, it diverges. So if you multiply 1/2 times 1 minus a divergent all over, it's going to diverge. We're not going to say it goes to infinity because it doesn't necessarily. It goes to infinity and negative infinity. Long story short, it does not exist. So does every geometric times 2 times 2 times 2, does every geometric series converge? The answer is no. Thank you, thank you, thank you. I didn't put the negative in there. In my mind, the alternator is, never mind. That's BC. Anyway, times -2 times -2 times -2. Nope, it diverges. So how do we know when it converges and how do we know when it diverges? Oh, that's no fun. That's boring stuff. How do we know when it diverges and when it converges? It's all based on the R and what the R is going to do when raised to higher and higher powers. It's all based on the common ratio and what the common ratio is going to do when it's raised to higher and higher powers. But as you guys are getting this set up, I'm going to go ahead and write out what I really want you, even though the book just gives this little baby formula and says, oh, it's so obvious, it's so cool, it's so simple. Yeah, no, I'm not a fan of that. Because it has big implications. So especially here in honors, we will write out exactly what's going on. And exactly what's going on is the limit as n goes to infinity, s sub n equals the limit as n goes to infinity, a sub 1 times 1 minus r to the n all over 1 minus r. Which will equal the infinite sum of, we'll just say our nth term, when. Okay, it's time for us to talk about the when. We saw two different examples. One of them converged to the formula that you see down below. A sub 1 times 1 over 1 minus r. One converged. And the reason why is because r was 3/10. It does not matter where it starts. What it matters is what it's being multiplied, what the terms are being multiplied by in the series. Since r was 3/10, yes, it converged, and it converged to that little baby formula here at the very end. But then the next example I gave you did not converge. It diverged because r was now equal to -2. So here's the idea. And maybe some of you have already come to this conclusion. If it depends, the convergence or divergence depends on the value of r, the common ratio. When will a common ratio raised to the nth, what kinds of values of that r are going to make the series converge? When it's less than 1, fractions less than 1, 1/2, 3/4, 5/6, 11/12, 1/3, all of those fractions will go to 0 as the powers get higher in this formula. All of those fractions will go to 0, but does it have to just be positive fractions? How about -1/2 raised to the n? Is it -1/2 squared and cubed into the 4th? It's going to be bouncing, but what's it going to be bouncing towards? It's going to be bouncing towards 0. It will be converging, even though it can't quite make up its mind what direction it wants to go towards 0 from. Negative fractions are still okay as long as they're less than 1. Why do we say less than 1? What's going to happen if r equals 1? Well, if r equals 1, 1 to the infinity is just going to be 1, but then we get 0, but we also get 0. 0 over 0. Oh, that's complicated. It's what we call indeterminate. Too much calculus now. But long story short, think about it this way. What if, you don't have to write this down, but what if I gave you a series where we had 2 plus 2 plus 2 plus 2 plus 2? Is this geometric? The answer is yeah, because r is equal to 1. But is this going to converge anywhere if I just keep on adding 2's? No. First sum is 2, second sum is 4, third sum is 6, fourth sum is 8, next sum is 10. It's just going to keep on getting bigger and bigger and bigger. It's going to diverge. So, doesn't exist. Remember, that term is diverge. The series is going to diverge. It's going to diverge whenever the absolute value of r, positive or negative r, is greater than or equal to 1. We already saw when r was equal to -2, something similar would happen if r was equal to 5 or 7 or 13 or 122. Any of those numbers raised to bigger powers are just going to keep expanding. There will be no convergence occurring. And we just saw, well, even if r is equal to 1, there's no convergence happening. The sum is just going to keep on expanding, expanding, expanding. Similarly with -1, it's going to keep expanding, but in a negative direction. What's the word that describes an infinite series that exists or an infinite sum that exists? Converge. Good. Converge. When? Well, what are all the other numbers besides absolute value of r greater than or equal to 1? Absolute value of r less than 1. Another way of putting it, r is in between 1 and negative 1. So whenever r is within, not including, negative 1 to 1, the infinite series will converge, and it will converge to the infinite sum, which can be found by the formula up above. But once again, this formula will only get me to a sum when the series converges this sum will only exist for converging geometric series. And the reason it will only exist for converging is because convergence only occurs when r is in between negative 1 to 1. And for any value in between negative 1 to 1, what's going to happen to this little guy? As n goes to infinity, as the powers get higher of any fraction in between negative 1 to 1, that little part goes to 0. Write it. Show it. This little part will go to 0. And if that little part goes to 0, of course the formula is what it is. Of course the limit is what it is. So what does LIM stand for? Limit. What's the little arrow stand for? Why do we need n to approach infinity? What's the whole infinite idea that's going on? How many terms am I including in my sum? Infinite. So I need n to go to infinity. I'm taking my nth partial sum. For any r in between negative 1 to 1, this value will go to 0. All the n's will now be gone, and I can just end with a sub 1, the first term, times 1 over 1 minus r. Excellent job. If you are some sort of highlighter star kind of person, I would highlight and star that entire box. Not just the little baby pre-cal formula that says, oh, no, it works whenever, use it. It works whenever r is in between negative 1 to 1, use it. I don't want you guys to just come away from this section holding this, but holding some of this calculus introductory stuff in your head as well. Okay, with that, let's play with some examples. Dual page. Oh, did you? What is it? 517? Oh, 714. 5.7142857. Yeah, there you go. Now he believes me that much more. I don't honestly know what those examples are. We'll come back to those examples. I don't know who they are. Ready, set. All right, what should we do for number 76, guys? Why? You're going to plug in infinity and make John sit through another 100,000 terms? No. How do we think about it? Use your formula. And your formula says, okay, let's take the limit as n goes to infinity of, we need a sub 1, 1 minus r to the n all over 1 minus r. Because you have to memorize this formula anyway. You're just adding a little bit of calculus to it. You have to memorize the formula anyway. You're just putting a little bit of calculus to it. So guys, who is the first term? Nope. The first term, we would plug in 0. Anything to the 0 power is 1. If we were to actually start plugging in stuff, it would look like this. It's infinite, so at some point we just have to do a dot, dot, dot. Look at the first term. Anything to the 0 power is 1. What's 4 times 1? 4. So my a sub 1 is 4. 1 minus, who's my common ratio? 0.2. 1 minus 0.2 to the n all over minus 0.2. What can we say? Since r is 0.2, as n goes to infinity, what's going on to this little term right here? Good. The whole thing converges because this piece will go towards 0. So you end at that little pre-cal formula that I suppose you could memorize. 4 times 1 over 1 minus, decimals. Isn't that just 1/5? Really? With the decimal, you just see it's 5, super easy. Cool. I don't. Fractions, I see it, because with the fractions, I'm like, oh, hey, isn't that just 1 over 4/5? Isn't that the same thing as 4 times 5/4? But it's okay. I mean, Colby, if you see 4 divided by 0.98 is 5, I mean, that's cool. That is really cool, actually. I can't divide 4 divided by 0.98 really easily in my head. Or 0.80, sorry. 4 divided by 0.80. Okay, so 5, done. Dun, 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 dun. How about number 80? Why? But remember, can't it be bouncing around and still converging to a value? I just don't like it when it's bouncing around and going 2 opposite directions and not even going to a value, going to infinity. That's bad. That's very bad. But this one, you're right, it is flippity-flopping, so there must be some sort of negative r going on. Well, hold on, kiddos. Can't you find the r? What is the r? What's going on? I see division by 5. Couldn't that be multiplication of 6/5? Now, if you don't know that, do you guys remember for geometric, you can take one term. If you're pretty sure it's geometric, you can take one term and divide it by the previous term to say, hey, how did we get here? So you could have done it this way also, 25 over 6 times 36 over 125. That's another way to figure out that 6/5 is equal to r. You didn't have to do it mental math. You could have done the second term divided by the first term, like the beginning of our notes say. But that would have been a common r, or our common ratio. But guys, hold on. Wait. Do we even need to go much further? What can I say? It's greater than 1. So what's going to happen to this infinite sum? My series is going to diverge, aka I could say my sum does not, my infinite sum does not exist. Does that kind of make sense? As you see that r is greater than 1, less than negative 1. Oh, we already covered all of that. And we covered that too. Okay. There's some calculus notation, but we're already using it. We don't need to write it again. Okay. Kiddos, this is officially, in some senses, the end of section 9.3. Homework is going to be due tomorrow. I'm going to go ahead and pause the video because we have one logistical thing to talk about.